So the number of columns in the first has to be the same as the number of rows in the second. So the two that they gave us up here, A, is a 3 by 2, and B, it says, is a 2 by 3. So in order to be able to multiply, these two have to match. Okay, those two in the middle. The columns in the first matrix have to match the rows in the second matrix. If those are not the same, you cannot multiply. Everything we did Friday was all 2 by 2s, so they were all the same, so we could do that. And then to tell the size of your answer, it's what's left. My answer will be a 3 by 3. And that's what it says in that little second sentence right there. The product would be a 3 by 3. So when I give you matrices, the very first thing now you need to do is check to see, can you actually multiply them? And then also check to see what size your answer is going to be so that you know what it should look like when you set it up. Okay, again, the number of columns in the first has to match the rows in the second. If they don't match, you just put not possible, can't do it. Other than that, the process is exactly the same. We're going to do just like we did on Friday. Rows by columns, we multiply, and then we add what we have. So what I want for you to do is tell me with those 4 right there, can we multiply them? And if so, what size is your answer going to be? Okay, they are giving you A and B. They tell you the size as the subscript. So I want to know, can you multiply it? Yes or no? And then what size is your answer going to be? So take a second and that is. A 3 by 1 and a 1 by 4, can those be multiplied? Okay, check your number of columns and rows. Are those the same? Yeah, and what size would my answer be? A 3 by 4? The leftover parts? Does that make sense? Okay. What about 4B? Can I multiply those two? Are those the same? No, can't multiply. So we would just put not possible if I gave you those two sized matrices to be able to multiply. What about C? 1 by 3 and 1 by 4. Can those be multiplied? Nope. And then a 1 by 6 times a 6 by 2? Yes. And what size is my answer going to be? A 1 by 2. Okay. That's the very first thing we need to check every time we're supposed to be multiplying. Can we multiply them? And then what size is my answer going to be so I know what the setup should look like? Everybody ready? Okay. So here's the first one. Again, the first thing we want to do is check to see if we can multiply. What you're going to need to do is, what is the size of the first matrix? What is the size of the second? Can they be multiplied? And if so, what size will our answer be so that when we start working it out, we know what the setup should look like. So if you'll take a minute and write those two down. What's the size of the first one? How many rows by how many columns? 2 by 3. And then the second one is a 3 by 2. Okay. So can we multiply? Yes. And then what size is our answer going to be? 2 by 2. Okay. Other than that, the process is going to be exactly the same now that we know we can multiply. We want to label our rows in the first matrix and our columns in the second matrix. And we're going to set up our little chart over here. Whoops. To help us keep organized. Row 1 by both columns, and then row 2 by both columns. Now it's exactly the same that we did on Friday. We start with the first element in each one. We're going to multiply 2 times 3. That gives me 6. Then we're going to multiply 0 times 1. Remember, across with the left, down with the right. 0 times 1 is 0. But this time, unlike Friday, we have more elements in the first row and more elements in the first column. So we have to continue And we're going to multiply 6 times 2 now. 6 times 2 is 12. And so then we can add all those together. 6 plus 0 plus 12 gives us 18. That goes row 1, column 1 in my answer. And then we're going to do exactly the same thing, but this time we're going to go row 1, column 2. So we take the first element in each and we multiply. 5 times 2 gives me 10. Move across and down. 0 times 0 is 0. We move across and down. 6 times negative 6 is negative 36. And so when I add those together, I get a negative 26 for row 1, column 2. And then we're going to do the same process again, but now with row 2. First element in each. Row 2, column 1, negative 1 times 3 gives me negative 3. Then negative 2 times 1 is negative 2. And then 0 times 2 gives me 0, which is going to add together to give me a negative 5. And then again, row 2 times column 2 has to happen. So negative 1 times 5. Negative 2 times 0. And then keep going. 0 times negative 6. And so we end up getting negative 5. So that is my answer. It is a 2 by 2, like we said it should be. And those are the new elements in the product. So other than checking to see if the sizes are what the sizes are and can you multiply, everything else is exactly the same. Okay? Everybody good with that one? Okay. Got a couple people still writing. I'll move it up in just a second and try the next one. All right, so the first one is a 2 by 3. The second one is a 2 by 2. These two do not match, therefore I cannot multiply, so I just write not possible. Does that make sense? Okay. Try this one. This one's a little tricky in the way the answer looks. This always confuses tricks. 1 by 3, and the second one is a 3 by 1. So they can multiply. And what size is my answer? 1 by 1. A 1 by 1 is literally going to be one number, okay? You have one row and one column to multiply. So that's all you're going to have. So we're going to multiply 4 times 6 gives us 24. And then we're going to multiply negative 2 times negative 4, which gives me a positive 8. And then we multiply 0 times 1, which gives me 0. So when I add that, it's, again, a 1 by 1 is just simply one number in a matrix. And for some reason, questions like that always confuse people. I think it's just because I'm not sure what a 1 by 1 looks like. It's just one number. Is everybody okay with that one? Okay. Try this one. What size is the first one? 2 by 2? What about the second one? 3 by 2. Can I multiply these? No. No, because the number of columns in the first does not match the number of rows in the second. No, you cannot. Order with matrix multiplication, order matters. If you change them around, it's a completely different problem. Okay. Now, if they were switched around, then we could multiply, but because they're the way they are, we can't multiply them. All right. Try that. So if we're doing these 3 by 3 times a 3 by 3, it can be multiplied because the columns and the rows match. And what size is our answer going to be? It's also a 3 by 3. So I have now 3 rows and 3 columns. So when I set my chart up, I need to make sure I do each. Bless you. Ah. All right, so we're going to get the process started. 1 times 4 gives me 4. Across and down, that gives me 0. And then across and down gives me another 0. So in my, whoops, wrong number. In my answer, row 1, column 1 is going to just be 4, because 4 plus 0 gives me 4. Then I do the same thing again with row 1. We're going to multiply 1 times 2, which gives me 2. And then 0 times negative 1 is 0. And then 2 times 1 gives me 2. So 2 plus 0 plus 2 gives me another 4 in row 1, column 2. Then we're going to do the same thing. 1 times 0 is just an extra column and an extra row. It gives me 0. And we're going to go 0 times negative 2, which is another 0. And then 2 times 2 gives me 4. And so for the row 1, column 3, I get another 4. Everybody okay with those? 4, 4, 4 across the first row. Okay. All right. Then we're going to do the same thing now with row 2. Negative 1 times 4 gives me negative 4. Negative 2 times 1 gives me negative 2. And 0 times 0 gives me 0. And if I add those, that gives me negative 6 in row 2, column 1. Then we're going to go row 2, column 2. So negative 1 times 2 gives me negative 2. Negative 2 times negative 1 gives me a positive 2. And then 0 times 1 gives me 0. And so those actually go to 0. And then we're going to go row 2, column 3. That's 0. Negative 2 times negative 2 is a positive 4. 0 times 2 is 0. So I get, whoops, I get another 4 as an element. So second row should be negative 6, 0, and 4. Everybody okay with that one? Alrighty. And then repeating the process one more time because we have one more row to go. We're going to go 3 times 4. That gives me 12. And then 1 times 1 gives me 1. And 0 times 0 is 0. So that gives me a total of 13 for row 3, column 1. And then we go again. 3 times 2 is 6. 1 times negative 1 is -1. 0 times 1 is 0. So that adds to give me 5. And then last one, whoops, try that one more time. 3 times 0 is 0. 1 times -2 is -2. And 0 times 2 is 0, so we get a -2. So the last row is 13, 5, and -2. So that is the final answer for the multiplication. Remember what I told you guys, though, like on the test, if you, especially on a one this big, you're not going to get it wrong if you miss one number. I'm just going to take points off depending on how many numbers you miss, okay? So as long as you get a couple of them right, you'll at least get a few points. But that's the biggest that we're going to multiply. We're not going to multiply any further than that. Anybody have any questions?